A very good morning to all of you students. Welcome back to your mathematics class. Today we are going to continue the substitution method in integral calculus. Last class was the introduction to your substitution method, and I hope you have all understood the requirement of this particular technique. Okay, so today I will be continuing the same class and I will be giving you certain example problems where you will understand better that how a proper substitution can help me to solve the problem. Okay, so one by one, let's go through the different types of problem. So here you can see in the board, I have written type 1. Here, the first integration is integration of 4x plus 2 multiplied with the square root of another function, that is x square plus x plus 1. Now children, a proper substitution can help me to do the particular problem. So let's understand. A proper observation is required before jumping into the solution of the problem. So, have a look on it. Here, this is something which is in the square root, and this is something which we really don't require, and this is something should be eliminated to make the particular integrand simpler. Keep it in your mind, children. We know the formulas of the standard integrals. Our aim should be to convert the integrand into something whose integration is known to us. I hope this point is very clear to you. Let's substitute this particular function under the square root. See, x square plus x plus 1. If I am going to substitute this one as, say, t. So I am putting it as t. Then what will be the derivative part? Changing the entire variable x into a t variable is not sufficient. We have a dx part. It is also important to be changed in dt. Am I clear? What I said? Let's understand it elaborately. Differentiate both the sides. What are you going to get? See? So this is the one I was talking about. See children, we are getting something very close to the other two things present in the integration. Okay, so what is missing? Can I write this particular integration as, take a 2 common from it? What are you going to get? See, if a 2 is common from the part, we are going to get, please focus on the one I am writing here. This 4x plus 2 is again written as 2 into 2x plus 1. And definitely I hope you understand what is the requirement of this 2x plus 1. This into dx is going to help me out to write down the value of dt. Is it okay? Now I am going to write this entire part as dt. Correct. And this is root over of t. Okay. So let us write down in the place of 2x plus 1 into dx, I am going to write dt. And this is becoming root over of t. Now please have a look till this point. This is substituted as t. Someone can even take t square, no problem in that. Okay, it's your choice. I and you all must concentrate in the one point. The integrand must be simpler. The integrand, the new integrand is ready in front of you, whose integration is quite easier than the one we were having. Okay, now root over of t, dt. Now its integration and how I'm going to handling this. See, root t is t to the power of half. Now I'm going to write down the answer as 2 into t to the power of half plus 1, that is 3 by 2. And this 3 by 2 will be coming in the denominator. Now please make it reverse. And never forget to put a c there. Now, is this enough? Is the problem finished yet? No. Why no? Because your problem was not in the terms of t. My question contains a variable x. I have converted into t for my own convenience. So the final answer must be put in the original x variable. Okay. So this is t. In the place of t, please do put there. We have to put here x squared plus x plus 1. And then it is going to finish. And this is what? 4 by 3. Fine, students. So this is the first type. I have solved it in front of you. A similar type. Another problem in the similar type I have chosen for you. Here it is written. What's the difference? Here it was in the multiplied form. Please have a look on that. I'm going to rub this first one. I'm going to rewrite the problem. Second one I have chosen for you. And let us have a proper substitution. Okay. So what was the problem? 6x squared plus 1 dx. I'm writing and I'm discussing with you. Please focus in the denominator part, which is in the cubic form. It can be in the cube root form also. It can be in the 10th power also. It can be in the any type of power. But a proper substitution is going to definitely help us out. Let's understand. Now I hope by following the first problem, it is very clear in your mind that we need a proper substitution. And now in this case, since it is falling at the same time, it should be substituted as t. Okay, now let's have a derivative of this. That is, I'm talking about dt. So find out the derivative of this one. What it is going to give me 12 x squared. Please do focus here. Plus 2 and or dx here. Now I hope many of you have understood that we have already reached a nice destination. Yes or no? So what is missing in the numerator part? Yes, or 2 is extra here. So can I write the 1 as 2 into 6x squared plus 1 dx as dt? I hope it is clear. So a 2 is required here. Fine. A 2 will be divided. So let me multiply a 2 in the denominator, and to balance it I can have a 2 here. Please go through this one. Again, see, the denominator part is t and the numerator is already made as dt. Is the substitution part understood or not? Please do focus in this part. Okay, this is only the heart of the problem. The rest is quite easy. Everyone can do it. Now I'm going to wrap this part and I'm going to continue the problem from here. So I'm satisfied. So I'm going to substitute here dt and in the denominator as t cube. Okay. Now t cube can be even written as what? T to the power of minus 3 dt. Now all of us know the value of it, the integration of t to the power of minus 3. Okay, let's see. So it is minus 3 plus 1. What should I put here? Minus 2. And in the denominator it is again minus 2 plus c. Fine. But last, the most important work is still left out. What is that? To substitute to change this t variable into x variable. Okay, so that's a very important thing. In the last slide, I'm going to do that. So minus 1 by 4, because this 2 into 2 becomes 4 and the minus comes out, and the t, what was the t? 4x cube plus 2x minus 5. Let us substitute the 1. 4x cube plus 2x minus 5 to the power of minus 2 plus c. Have a look. So, I hope the type 1, such type of problems you will be able to do. Now, let's move to type 2 problems. Okay. So, this is the problem, that is 1 by x square into 1 plus x square, but there is a root over again dx. Now, what I want to tell you, a very shortcut method can be done for solving this problem. This particular problem will be only either of 1 or of 2 marks. So, definitely a simple trick can help me out. Okay, so let's see that. Either you can substitute x square plus 1, this particular part, as a t square. Many students go for that. Okay, because whenever they find a square root, so they opt for a t square. That is also correct. But if I am not willing to convert it into another variable t, so in that case, do one thing. Take a x square out of it. But how it will come out? See what I want to say. Please have a look on it. See, from this, if I am going to extract x square, so it will come out as, is this clear? See what I wanted to tell you? X square is actually common, so that's why it became 1 by x square plus 1. But when it is coming out of a root, it becomes 1. Okay, so one more x square is there. So x square and x multiplies to, yes, what it is? X cube. So let me substitute the entire thing here in the main intriguing part. Okay, so see how I am doing. I just show you a rough. Here it is. Fine. So it became x cube after taking that common, and the denominator of the second denominator part, that is, which is under the square root, becomes 1 by x square plus 1. Okay, students. Now, this is the one I needed, because if this entire part, what I am saying, this entire part becomes t. Now you tell me what is going to be dt then? Yes, dt becomes, if this entire part becomes t, then the derivative of this entire part becomes, yes, that is minus 2 by x cube, isn't it? So, minus 2 by x cube, that means if I am going to put a minus 2 into dx, so my work is done, but there is no minus 2 actually. For that I need to balance a 1. Is it okay? The 1 under square root is taken as t, and the rest becomes, with the addition, with the multiplication of minus 2, as dt. So I am going to replace everything in terms of t now. So after replacing everything in terms of t, how the integrand becomes now? It becomes a very simpler one, that is, it is dt and this is root over of t. And after that, you know what to do. In the last problem we have done this one. This is t to the power of minus half, and t to the power of minus half integration will be t to the power of minus half plus 1, in the denominator minus half plus 1. I am going to write that. So the conversion into t, I hope it is clear. So minus half In the integration, I'm going to write minus half plus 1, that is half. And in the denominator, there is one more half. It comes out as 2. So I'm erasing this and a plus c. So this 2 cancels. And the last but not the least, the last part of the job is what? To reconvert the t into terms of x. Okay. So in the place of t, what I am going to put here, this is 1 plus 1 by x squared. Okay. So minus, never forget to put that. So 1 by x square plus 1 as t and a root over, you can put like that only. This is your answer. So here I have not converted in, I have not directly substituted it into t square. That also you can opt for, that is also right. But I hope this method is clear to you. So along with this next category, I have already chosen one more problem for you where I am going to substitute something else from the very beginning. So have a look on the second problem. What it is written? It is root over of 1 minus root x by 1 plus root x. Okay. Now, what I want, so I'm rewriting the problem here and I want you to think about a proper substitution. You have already gone through this type of substitution in your inverse trigonometry problem and even I think in derivatives also. Now, let us recall the formula. If I am going to change here the root x into some cos, that is going to help me out, isn't it? So I know many of you have already gathered the idea of a proper substitution. Okay, so let me substitute this root x, or I am going to substitute x as cos square theta. Have a look here. I'm going to substitute x as cos square theta. Then the root over of x will become cos theta. So root over gone. The first root over gone. Correct. But that is not enough for me. We have to think about this dx. We shouldn't be till we get the value of that. Okay. So dx 2 cos theta minus sin theta d theta. So let us substitute everything in the places of x, which is now filled up with, let us substitute filled up with thetas. Okay, so I'm writing a big root over and 1 minus cos theta, because this is cos square, so root x is cos theta. Once more I'm telling you this one, So this is okay. Now dx, in the place of dx, substitute everything here. Okay, so what it is? 2 cos theta minus, let me take that if I wish to, minus 2 outside, and cos theta and sin theta and d theta. Okay, I'm rubbing here, erasing this extra thing. I hope that part, that work is over. So okay, let's not rub everything. So let me make a side of it. That will help me. So dx, so that you can match up with what I have done. Okay, see. Now please stop here and once more recall the substitution. Okay, now the entire problem, which was in terms of x, is now in terms of what? Thetas now. Okay, now let us find out or rationalize or something way out to get rid of this root over. The best is rationalization. Okay, I hope you are you must be thinking, why I know the formula of this one, that is tan theta by 2. Yes, why not ma'am is using that? You can go with that also, no problem in that. Okay, so we have different methods to complete the problem. It should be correct, that is important. So I'm showing you one method. You can opt for another method also. That is also right. If you're getting the right results, no, I will give you full marks for that, and anybody will give you full marks for that. Okay, so I'm going to use rationalization here. So imagine after rationalization, what you're going to get. So I'm going to multiply 1 minus cos theta again in the numerator and a 1 minus cos theta in the denominator. Clear? So after that, what comes out? Let's see that. After that, you're going to get a square over here, and this is, make clear? So 1 minus cos theta in the numerator and a 1 minus cos theta in the denominator. So this square root is over, no? This will come out as 1 minus cos theta, and this is sin square theta, and it will come out as only sin theta. Is it okay? Okay. So I'm writing here as 1 minus cos theta, and here it is sin theta, and you are already having here cos theta, d theta, no, one more sin theta and a d theta. See, is it okay with everybody? See, fine. Now definitely you are also thinking the same way, cancellation of a numerator and the denominator. So let's cancel. So what is the residual part here? Cos theta into 1 minus cos theta, cos theta into 1 minus cos theta. So let's multiply. So it is cos theta minus cos square theta, d theta, and we even know we can separately integrate them also. No, we can separately integrate them. So I'm going to do the same here. I will integrate this one separately and this part even separately. So rewriting this part. So rewriting this part up to what we have achieved, I'm going to write this. Remember, okay, this minus 2 is multiplied throughout. Don't miss it out, okay. So this is minus 2, and let it be outside only, no problem with that. Cos theta. Now, can I substitute integration of cos theta? Yes, we can, because we know that. Okay, so this is sin theta, this over. Very happy with this part. No problem with this. But I do have a problem with this one. With this part, I do have a problem. This is not giving me the direct formula. Okay, but it can be turned into a direct formula if I'm going to multiply a 2 there and 2 outside. See, in the denominator. Yes, what it recalls? It is the formula of 1 plus cos 2 theta, isn't it? So what I did, a cos square theta, whose direct value is not known to me. To get the value of the integration, what I did, I multiplied a 2 with there and in the denominator, correct? So now I am getting 1 plus cos 2 theta. So I am writing the same here. 1 plus cos 2 theta and a d theta here, and please close all the brackets. So I am erasing this, it's over, this part is over. Now please see where we have reached, see. Okay, so after that, please do multiply the 2 which is outside for such a long time, waiting for it to come inside. No, so let's move it inside. Fine. So minus 2 sin theta, correct? And this minus 2 and this part will cancel down, and I'm going to get a plus here. So 1. What is the integration of this 1? This is theta. And what is the integration of this cos 2 theta? This is sin 2 theta by 2, because I hope we have made it clear in the last class. Okay, so this is plus c. This is plus c. Okay, so this is the one you are getting. This is one method I have shown you. If you want to convert it into some other variable in the same type of part. You can begin with a rationalization also. We can move with a T also. Okay, students, I am telling you, I am showing you different type of techniques. You can choose something else also. Correct? Now, listen all of you. Is this the entire thing completed yet? No. Why not? Because we have to complete it. We have to finish the problem in the value of x. What was x? Like this. X is cos square theta. X is cos square theta. So, one by one, you have to convert entire thing in terms of x only. Okay. So, here in the particular problem, you can find, see, you can find here that cos square theta is x. So, you all know that 1 minus cos square theta, that is 1 minus x. It is sin square theta. So, what is sin theta then? It will be root over of 1 minus x. What is sin theta? Root over of 1 minus x. So, I am going to substitute this root over of 1 minus x here. Here in the part sin 2 theta by 2, we can write sin theta, cos theta, and the 2 will cancel. So, you know what is sin theta, you know what is cos theta, you will be substituting here. And the last but not the least, this is theta. Okay. So, how can we find theta? If cos theta is root over of x, then what is theta? So, I have shown you the conversion also. I have shown you the conversion to on x variable also. So, one by one you are going to substitute here with the plus c. This is going to give you the answer. Okay. So, see students. So, this two type of problem I have done here in this particular session, and you will carry on your problems back at home. I will be providing you some problems in the PDF material. You will please go through all the problems I will be sending you after this video session. Okay. And one more thing. This is only the beginning of the different type of problems in substitution method. We have lot in this entire substitution techniques. Okay. So, please keep on practicing. We will come back with more techniques, more types. Okay. Have a good day.